On chapter 4, we did a marketing application, which is where we put together these surveys. Oh, no, this one is where we put together an advertising suggestions for the client to advertise their new development with 5 alternatives. Everybody remember that, right? From last week. Then, now, we start talking about this marketing research project using linear programming, where we were asked, we've been hired to do a survey of 1,000 households with all these contingencies. Interview at least 400 households that happen to have children. Interview at least 400 households that don't have children. They said they want exactly 1,000 interviews. But we have to determine how many interviews have to take place with all the 4 options. Here are the 4 options. Household that has children, and the interview was done during the day. Household with children, the interview is done at night. Household without children during the day, household without children at night. We have to figure out out of those 1,000 interviews, how many will be in each of those 4 categories. And that's why there's 4 decisions in this exam. How many during the day, at night, for each. Those are the 4 decisions. So we got to the point to where we started writing the objective function and constraints on this one, correct?
Yes.
Okay, I'm going to keep going a little fast because I know this is all review. Matter of fact, we really talked about these last week where I said, write this out as it's worded. You remember that a little bit? At least, okay, that would be greater than equal, correct? 40% of, 0.40 times. Of is multiplied. The interviews for households with children, so whatever variables represent households with children, must be conducted during the evening. So on the left-hand side would be just the variable for evening with children, greater than equal to 0.4, and then you use algebra. We get to that real quick to review. Evening with children greater than 0.4 of all the with children interviews. Then we would take 0.4 times that, which is DC, move it to the other side, so we get negative 0.4 DC. 0.4 times EC, subtract it, 1 EC minus 0.4 EC leaves positive 0.6 EC. What's left on the right? Nothing, 0. But we got all the variables on the left side, so it's ready to go. And then the other one said, 60% of the interviews in households without children must be in the evening. Here's all the households without children interviews, times 60%. The evening ones have to be greater than that. Now, 0.6, subtract both sides. These are in your future, for sure. Lots of, as a matter of fact, even your homework has these sentences, 60% of this, 40% of that. And again, let me emphasize, you try writing it out just like the words are saying. Make sure you have everything included, and then it's just a matter of applying algebra. That's my suggestion. The one I don't know if we talked about this one right here, though. The total number of households interviewed during the evening must be at least as great as the number of households interviewed during the day. Did we talk about this one? Does that look familiar? There's 4 variables. 2 are the evening, with and without children. 2 are during the day, with and without children. And this whole sentence says, all the interviews in the evening must be at least as great as all the interviews during the day. Help me out to start with. Is that less than equal, greater than equal? Because you guys are at least as great. What would that be? Less than equal? I think greater than equal to. We'll go with that. Now on the left-hand side would be the total number of households interviewed during the evening. I don't have the variables memorized, but the evening, there's no children would be N. Help me out. Come on. ENC is without children. ENC, and with children that is just NC? EC. I know you guys probably get this. EC plus ENC greater than equal to, now the variables for daytime, which are going to be DC plus, is this DNC then? Does that sound right? For the variables, DC and DNC for the ones during the day? Yeah. Everybody look? But you're not done. Now you just wrote it like it's worded. You got to use some algebra to get the variables from the right side and the left side, which is subtract DC on both sides, subtract DNC on both sides, and you end up with EC plus ENC minus DC minus DNC greater than equal to. There's nothing left on the right, so we put 0. You just moved it all over by subtracting it. And that's all demonstrated right here. Evening, greater than or equal to the days, subtract the day ones, so it's all on one side, greater than or equal to 0. If you're entering this in on Excel, underneath this variable is a -1, underneath this variable is a 1, a -1, and a 1, and the right-hand side is a 0. Same with the software, you would enter it in just like that. So, I put this one on Excel. I don't think that we went over this yet. It solved the answer. So we're going to do it. I set it up just like we talked about. Here's the cost, which we're trying to minimize, depending on how many interviews we end up having to do in each of the 4 categories, multiplied by the cost to get this as low as possible. Here's our left-hand sides. This is what you would be handing in 3 of these. Sheet 1, Sheet 2, Sheet 3, just hit the plus. 3 of these is what you're handing in for those 3 problems. You're setting it up just like this, ready to go. And I will probably use solver and see what the result is, because that will pinpoint, that will let me know. The work is right here in this cell and this cell. Because once you do this top constraint left-hand side, I don't know if you remember me saying this last week, or Monday, you just copy and paste it down. As long as you're using the dollar signs, let me show you, correctly, you never want these cells to change, because every left-hand side is going to multiply times this. So I have E15, F15, G15, H15, all with dollar signs, so when you go to paste it, it stays on 15. But that E6 will turn into E7, E8, E9, E10, E11 as you copy them, paste it down. And that you do want to change. So you just have all the work right here, copy, paste, and right there is the work. The rest is just entering the numbers in and getting it set up. If you use one of my old spreadsheets, one that's posted as your start, that's fine, no problem. You're going to have to probably eliminate some rows or get rid of a column, but you just go up there where it says insert or delete. Insert a row, insert a column. Just have your pointer where you want. Everybody with me? Here we go. We just got done setting up all the constraints and the objective function for that research project. How many interviews are we going to do during the day and evening? Go into data. Go into solver. I have it all in there already. Blah, blah, blah. We got check, simplex method, solve. Hey, yeah, of course we want sensitivity. Yeah. All right. How many evening surveys are we going to have done? Evening surveys. Anybody jump in? How many evening?
With children or without or both?
I'm sorry?
With children or without or both?
With what?
With children, without.
No, evening period.
So
There have to be with children and without children evening. What I'm asking about to ask you is, what is the total evening? And is it greater than the total day? Or are they equal? So what's the total evening? 520. What's the total day? 480, right? Isn't it? 480 versus 520, is that correct? So we definitely have more evening than day, which was the objective. Which is, what's the lowest cost? We're the ones that have to pay all these surveyors, and we got the prices for each survey. What's our total cost for all these surveys to be done, all 1,000 of them? How much? $20,320. That was the objective, to keep this as low as possible. I want to prepare you. This is where this is heading. You're going to have results, pictures on your quiz, and you're going to be asked questions. You know, how much is the total cost going to be for this? What's the lowest we were able to get it? Do we have more? How many total evening surveys are we going to be doing? How many total daytime? Things like that. So you gotta be able to be familiar enough with this to answer these questions coming up. So 240, 160, 240, 360. Summary report, real quick. I don't know anything to say.
I got a question.
Yep.
Allowable increase, the second row, it says 1E plus 30. What does that
Yeah, I forgot to mention that. 1E plus 30 is Excel's way of saying infinity. That's what that is. So you know how some of them have no upper limit or no limit on allowable increase, or some softwares will say infinity, I think, or no limit or something like that. That's what that's saying to you.
So it's the same as
No limit.
or whatever.
Yeah, I think it says no limit or something like that. And if you're using the 100% rule, this would be divided by infinity, and any number divided by infinity is equal to almost 0. So you might as well count it as 0%. So close to 0. All right, so now, any other questions? Going to the next one. Wait, which ones are we doing next? Let's do this one next. This is a nice, easy one. I posted this, so you have it there. The story, I typed it all out on here, so it's all right here. Floatway tours. This is you. Your floatway tours. And you decided after graduation that you didn't want a real job for a year. You wanted to take a year off. You're burnt out. You know, school was hell. And you went ahead while you're on this tropical island down in the Keys. I know, what are the islands below the Keys? To the left, to the right, to the east. Virgin Islands. You're down in St. Thomas. You've been hanging out on the beach. You're drunk and high all day, all night. You know, you're just having a great time. And it dawned on you, if you bought a couple boats, you know, all these cruise ships keep stopping, and they're looking for things to do. So if you bought a couple boats, you could rent them out and make some money. Sure enough, you had some student loan money left over that you already missed a payment on. But everything's okay, there's only been one payment. And you took that money and went ahead and jumped out and you got a small loan because you had some money. By the way, all commercial loans, this is the word I always heard, you have to have skin in the game also. So in most commercial loans, you have to have at least 10% of your own money. So you're motivated to make this work because you're going to lose your money as well as ours. If we let the bank say, if we're lending you this money, you're going to lose our money, you're going to lose your own too then. So you have motivation to make it work. And you've got 2 boats. And you cannot keep the boats in dock long enough to just clean it. It's being rented so much. And you say, I found something. And this is the kind of entrepreneurial attitude you need. You start out small. And you test it out. You keep your job and you work it out in your garage or your basement. And you don't spend a ton of money and get a giant loan until you know for sure that this is a great idea. And in this case, these boats you found out are a great idea. So now you want to open a full-fledged company. You've saved enough money off these 2 boats to put 10% down, and you got a loan plus your 10% for $420,000, and you're going to add at least 50 boats. This is how big your company's going to take off now. So here's the deal: you've got the money, $420,000. You've got at least 50 boats you're going to buy, and the companies you've been working with just a couple boats you have. One's called Sleek Boat, one's called Racer. You want to keep the goodwill, and you want to buy however many boats this gets you, but it better be at least 50. You want to buy the same number of boats from one manufacturer as you do the other to keep goodwill. In real life, by the way, that's a big deal. I was president of a computer company, and we had to always keep goodwill with Intel and AMD. When we did commercials, and Intel, at the end of the commercial, if we put that little ding ding ding, Intel, remember that? You ever see a commercial? Ding ding ding. They would pay for almost 90% of that commercial just because we had made sure that was on there. So there's definite benefits to having good relations. They would fly employees out to California for training, all on their expense, hotel, meals, flights. So having good rapport with these companies is a good deal. So you want to keep good rapport, so you're going to buy the same for each one. By the way, what I'm telling you are all constraints, there's limitations. Whatever I'm buying is going to be the same for each one. I want at least 50 boats. I only have $420,000 to spend. And then it says, you want to, whatever all the boats are, however many over 50 or 50 of them, the seating capacity's got to add up to at least 200 seats, based on what's going on. And you've had so much experience with these 2 boats that you realize you're going to, you can estimate the profit the amount of times daily those boats would be rented out. That would be your daily profit off each of those boats because of the seating capacity. Bigger boats rent for more money. So, as I stop right there, how many decisions are there to be made? Not all at once. We are recording. I don't think I picked it up. You guys are so loud. Come on. How many decisions?
3.
Right. not 3. I heard it. 4. Who, wait, there was a female voice. Thank you. 4. Because there's only 4 choices of votes. That's what this decision is all about. What is my combination of votes? It's going to be 1, 2, 3, 4. How many speed hawk, how many silverbirds, how many catman, how many classics? Here's the price for each one. Here's the seating capacity. Here's the projected profit. And as the owner of this company, you're saying, all right, this is a big deal. I want over 50 votes. You know, I don't care which ones these are, as long as I'm getting the same amount from each manufacturer. But I want to make sure that my combination of votes make the most money possible for me based on my estimates. Objective function, max or min? Very good. I don't know why I didn't write this out. Objective function, max, $70 times however many of boat X1, Sleep Hawk, $80 times however many Silverbirds, $50 times however many Catman, 110 times however many Classic. So that's that formula right there in the objective function. The optimal times the possible profit from each one. Within the constraint, let's start with this top one, 420,000. The cost of each boat has to be less than or equal to 420,000. There's that. 50 boats. We want at least 50 boats. However many of this Speedhawk, how many Silverbirds, how many Catman, how many Classies have to be greater than or equal to 50 boats. So I'm going to spend all this money. And then we got a 0 there. This is the one where we're saying we want to buy the same amount of boats from each manufacturer. So one manufacturer is offering Speedhawk and Silverbird, and we want to make sure however many from that manufacturer is going to equal the number of boats from the other manufacturer, which is Catman and Classy. Now we use algebra. Subtract x3 from both sides, subtract x4 from both sides, so you get 1x1, 1x2, negative 1x3, negative 1x4, equal to 0. That's going to be a binding constraint no matter what, because it's equal to 0. Those variables have to add and subtract to be 0, which will cause the same amount of boats from each manufacturer. The last one is seating capacity of 200. This boat has a seating capacity of 3. This one's 5, this one's 2. This expensive boat has a great seating capacity of 6. You see the advantages of that. And however many of each boat times their seating capacity has got to be greater than or equal to 200. Now what we just did is we went from an Excel setup backwards as if to write the objective function constraints by looking at this. I need you to be there. This is what this homework assignment is all about, getting to this point where you can look at one of these and come up with the objective function constraint. I mean, it's all right here. Max, less than, greater than, equal, greater than. There's the numbers, there's the variable names. All right? All right, let's solve it. We got everything covered. Let's see how many votes we're getting from each manufacturer here. Any questions? Ready? Solver. By the way, Max, I don't know what I'm saying. I was going to say, we kind of figured out a way to get this thing to come up on Max on Excel. If you're getting that weird one that comes up in blue, you can have this one. Does anybody with a Mac have a problem? Are they getting this one when they use Excel? I'm looking around, realizing I have the looks of people who haven't even checked. Is that possible? What class is this? What, are we in college? Wait, where are we? Just check. All right, sensitivity. Hey. Whoa. Hey, hey. Whoa. Hey. Oh, what up? Who cares? Wait. Every time I do that, it goes to a different spreadsheet. So hang on. If you have one open, it takes off to another one. My question is, how many boats are we ordering total? How many are we going to receive, according to this suggestion, of total boats?
50, 40.
Well, no. That's our, now I'll ask that question, you ready? What's the most daily profit we could be getting with this suggested boats combination?
Oh, 50, 40.
$5,000, $40 a day could be our max profit with this combination of boats. But how many boats? 56 boats. Are we buying the same amount from each manufacturer? Yeah, as you notice, we're only buying one boat, one type of boat from one manufacturer, the big one from the other manufacturer. So they're the same amount, but we're only getting 2 boats. The other 2 we're not even buying. Where am I here? I was going to ask, okay, hang on. What was there? What is it? Oh, yeah. Oh, okay. Our seating capacity had to be at least 200. Did we make the seating capacity? And if so, is there some slack or surplus? Yes or no on the seating capacity? Look at that carefully.
Yes.
I heard it. Say it again. I couldn't hear you say surplus. Of how much? 52. Which means we have 52 more seats available than the 200 we required. And all right, that's about huh? See it right there? 52 is 56. Oh, I'm sorry, 52 right there, yeah. Just checking. 252 out of 200. All right, how do we feel? This is posted. This is on Blackboard. All right, you'll see zeros here. Just do the solve if you want to get to the answer. What is this? Limits? Objective, result, blah, blah, blah. Oh, okay, here we go. I'm going to go here. You ready? If we decide to change it, if we add a constraint that looks like this, x2 must be greater than or equal to 1. By adding that constraint, we're forcing the output to change in a certain way. x2 greater than or equal to 1, and what will happen is our maximized daily profit will have a negative effect of how much?
$2.
Anybody?
$2.
Anybody? I heard you. Does anybody agree or disagree?
Agree.
Where do you see it then?
Reduce cost.
Correct. But the variable 2, the reduced cost is -2. Ignore that negative. Many of them won't put negative or positive there, so ignore it because sometimes it won't have it. You'll think, oh, I'm supposed to add. There's always a negative effect. And with this problem, a negative effect would be adding or subtracting $2 to that potential daily profit. Is this a max or a min? Max, negative effect, add or subtract $2. You got it. And this software, or Excel, happens to give you a hint that you should be subtracting. But don't rely on that. Your software never uses negatives on reduced cost, even though it could be subtracting. So that's why don't rely on that. Okay, I think you're there. Let's go to the third one. We've got a good speed going here. You ready, finance majors? Are you ready? I just want to know how many finance majors I have real quick, just so I know. Oh, several. More than Mark. Okay. Here's an example. This is the stuff you read at home. This is the stuff you read at home. Okay, here we go. Client got in where you're working, or you're an analyst for the company, or whatever it is, and there's $100,000 available, and you've been asked to put together the investment suggestion to invest this $1,000. You've been asked to keep the money within these 5 investments. And these 5 investments each have the estimated potential return in percentage listed there. All right? So you have these 5 combinations of how to invest this $100,000. And then it's saying, let's see, you recommend these 5, blah, 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 blah. Okay. Here's the deal. They said, however you're going to tell us how to invest it, we don't want either oil or steel. Now, let me make sure you understand what that means. 2 of these investments are oil, 2 of them are steel, and 1's government bond. So they're saying we don't want oil or steel to receive more than half the money, $50,000. Let me see what variables we're using. Okay. Let's talk about it. We don't want oil or steel to have more than $50,000 invested. Less than equal, greater than equal, or equal to 50,000. Less than equal. All right. Let's start though with oil. Over here should be something that talks about how much we would put of the 100,000 invested in oil, the oil options. Let me also ask you, how many variables are there in this problem? How many decisions? 5, because there's 5 investments. It's asking you Is it how many shares we're buying? Let me go back to the previous screen here. You don't even have it. Okay. This is all the information you have. You gotta say yourself, should A be however many shares of Atlanta oil we buy, Atlantic oil? But it's not giving us the share price, so it's impossible for that to be it. What is the variable A represent? Atlantic oil, something about it. What's the decision to be made? You are the one who's put the recommendation together for this $100,000. What decision has to be made about Atlantic oil? How much of the $100,000 you're going to put into that investment? How much? So A is how much. It's money. It's not how many shares in this case. How much? And then you have P, M, H, G. This is oil, oil. This is steel, steel. And this is just like a safe haven. Whatever money's not in oil and steel, you're going to put it in this nice safe government bond where you're guaranteed to make money even if the market collapses. Government bond is a fixed income coming in for till maturity. So now, this left-hand side has to represent what we're investing in oil. What am I doing? Almost there. Investing in oil. What variables would I use for the left side? A plus P. However much we're investing in this oil company, plus however much in this oil company, it's got to be less than or equal to $50,000. The other one says same with steel. 50,000, steel. Put a dollar sign. What represents steel on the left-hand side? Everybody should get this one. M plus H less than equal to 50,000. So there's those constraints. I'm sorry. Say again.
Individually under 50,000 or together?
Together. It says, let me read it again. Maybe I'm reading it wrong. Neither industry, there's only two of them that represent oil, and the two of them represent steel. So either industry should receive more than, or neither one of them should receive more. That's why it's less than equal. So they have to receive 50,000 or less. Here's oil, here's steel. It says government bonds should be at least, we're going to write this just like it's worded, and then we'll use algebra, at least 25% of the steel industry investments. Think about this. Let me start on the left side here. Government bonds should be at least, less than equal, greater than equal? At least. At least. Right? Is that greater than equal?
It's greater.
Is it? Okay, making sure. Diamond, don't stop. Do not stop. Don't get discouraged.
Okay.
You keep, I appreciate more than you can. All right. You're still giving me that discouragement.
No,
Okay, good. All right. At least 25%, 0.25 of times of the steel industry investments. Which ones are steel again? M plus H. You're not going to hand it in this way because you're not done. You know there can't be variables on the right. We've got to use some algebra. I'm multiplying 25% times each of those, and I get 0.25 M plus 0.25 H. Is that right? 25%? Okay. Now I'm going to subtract each one and bring them to the left. So now I have, is it either of these G? No. So I have G minus 0.25 M minus 0.25 H greater than equal to, nothing's left on the right, 0. So your constraint turns into this. And that's how you hand it in. Making sure there's no variables on the right. Here's the next one. The investment in Pacific Oil, which is the P, is a high return, high risk investment, and it cannot be more than 60% of the total oil industry, just like it reads. Pacific, P, cannot be more than, I was waiting for time, less than equal to, see, was that high?
I was on
Okay. Cannot be more than 60%, 0.6, of times the total investment, industry investment, which is this oil, right?
Yeah.
So which represents oil? A plus B. Thank you. Very good. Same algebra. You multiply both sides by 0.6, or I mean both variables by 0.6, so you get 0.6A plus 0.6P. That turns into that. Now you're going to subtract 0.6A and P. Here's where you have a P minus a 0.6P. right here, because you're subtracting 0.6A and 0.6P on both sides. So you end up getting negative 0.6A, 1P, minus 0.6P leaves a positive 0.4P, less than, equal to, and nothing's left on the right but 0. Negative 0.6A plus positive 0.4P, less than, equal to 0. Do these seem hard? Do they seem hard? Is it if you write it out just like it's worded, the algebra shouldn't be that hard. I mean, I think everybody in here has had experience with algebra. It's making sure you write it out just as you read it. It's the hint I give. It works 90% of the time writing out the way it's worded. There's this 10% of the time where the words are not quite the way you write out. But I'm not going to put one like that on the quiz on purpose, that's for sure. On the quiz, you're going to have some of these percentage type ones that you've got to write the constraint and then do algebra. It's going to be just like these examples. We have $100,000 to invest. Less than equal, greater than equal, or equal. Kind of less than
Greater
equal.
than equal.
If this were like, you have to buy a certain amount of shares, the price per share, you may not spend all 100,000, but with the safe haven, it's kind of like a money market government bond thing, it can take it can take pennies. So we will end up investing all 100,000. Is that where you're going? And so that's why equal 100,000 happens to be in this case. And I can see your argument for less than equal, kind of, because you may not be familiar with how all the money could be invested in this particular example in real life. So I'm going with equal. The variables, it'd be all the variables added together. Whatever the investment suggestions we're having for each of the 5 categories added together to have to equal 100,000. That's all we have. So I have A plus P plus M plus H plus G equals 100,000. I think we covered everything. Let's double check. All of these are right here. APMHA, max. Oh, how did I forget that one? The client says we want the highest rate of return possible with the suggestions you're going to make. So we're going to max, and we're turning this all into decimals. 7.3% is 0.073 times A plus 10.3%, 0.103 times P plus 6.4%, 0.064 M plus ... 0.075, 0.045. This is safe, that's why it's the lowest percent. It's not reality because can't get 4.5% and that's safe with investment. But there you go, now we have them all. Here's the objective function. We change it to percentages. Here's our constraints, $100,000, 50,000 max in each industry. Here is our unconverted government bond minimum, our unconverted Pacific Oil. You know you multiply the 0.25, subtract them, multiply the 0.6, subtract them, right? And now we have, here it is, all on Excel. $100,000, the 50,000 in one industry, 50,000 in the other industry. The 25%, the 60%. There's our objective function numbers. Are you ready? The question I'm going to ask you is, how much are we investing in the oil industry? Ready? Solver, check everything over, blah, 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 blah. Okay. Oh, wait. It automatically goes to a different spreadsheet when you run. How much are we investing into the oil industry? I can't hear you. 50,000, where did you get it from? A represents oil. That company's oil company. 20 plus 30,000 is 50,000. How much are we investing in the steel industry? 40,000. Government bonds, 10,000. What's the amount of money we would make in a year with this combination of investments? $7,550 is the most we can make. Just $7,550 is the most money we could make and stay within those limitations of the 50,000 in one industry, another 50,000 in another, the 25%, the 60%. Stay within those. That's the most we could make. How much did we invest again altogether? 100,000. Real quick, finance majors. What percent would this then turn into for the whole portfolio if these expected returns happen? Point what? What is it? What is it? He's dividing by 100,000 right now. Anybody off the top of your head? Come on. 0.0755, which is equal to 7.55% return on the portfolio. That's what that's telling you. We didn't invest in M, which is it's a steel company. I forgot the name of it. What is that? Anybody? All right. No. But if we did invest in M, we forced a couple $1,000 into M. We added constraint. M is greater than or equal to $2,000. Is the minimum maybe to get into that. $2,000. What? First of all, no matter what happens, it will have a negative effect on the objective function value because we're changing one of the optimal solutions for a variable. But how much? For each $1, each 1 unit effect that we change one of those variables is going to have how much of a disadvantage on our maximized outcome. Anybody see it? How much? I heard it, but I can't see it.
I can't see very well.
You can't see it? What do you mean?
I don't have glass. I make glass.
What should I do? Do that?
Oh, yeah, there you go.
Okay. How much, if we decide to force an investment of $2,000 into M, for every dollar we force, what effects are going to have? There it is. The reduced cost right there is telling you when you're changing one of the optimal solutions that right now has no suggested units there, you're always going to have a reduced cost. And that reduced cost is going to have a negative effect of 0.011, a penny, 1.1 cents for every dollar we're forcing an investment here. There's a disadvantage, and we're going to lower that maximized return. It's a negative effect. Add or subtract 0.011 times $2,000 that we're forcing into that investment. Add or subtract? Subtract. This is a max problem. Negative effect to be subtracted. That's reduced cost. Any questions? Because that's as far as we're